Hi there, this is the second video about polynomials, and today I want to talk about coefficients and exponents. But first I want to show you something. Just look at this over on this side. Just take a little minute and read that. If it looks like absolute gobbledygook to you, that's completely okay, because this is some instructions for crocheting. I could have put some music in there, or maybe some very cool cheats or something in video games that would make absolutely no sense to me. But once you play that video game, you know what they mean. Once you learn how to crochet, you know what all this means. Well, what I want to show you today is one of those things in math that once you understand what this stuff stands for, math becomes so much simpler. It's not about memorizing a bunch of rules. It's about having this deeper understanding so that if you forget the rules, you can just go back to what these things stand for and you can develop your own rules. Not develop your own rules. You remember the rules because they're really simple. And today the big thing I want to talk about is the difference between coefficients and exponents. Now, I should have had something like this written up here because we need to have an example. So this, the number out front, is a coefficient. And it's okay if you refer to it as the big number out front, but you need to know that when an instructor says coefficient, they're talking about that. And this is your exponent. And the exponents are the little numbers up on top. Those are the superscripts. That's the fancy, I don't know, fancy word for it. And that, of course, the x in there, that's your variable. But today we're going to worry about coefficients and exponents. Now, there's a difference. Not everybody remembers that. So let's look at coefficients first. I kind of wrote this backwards. I should have had x plus x plus x is 3x. Okay. And part of this is mathematicians and scientists just wanted to have a bit of a shortcut. I mean, really, if you looked out the window and you saw some cats, you wouldn't go, look, it's a cat and a cat and a cat. No, you'd say, look, there's 3 cats outside. Okay. And it's addition. So 5RT is the same as RT plus RT plus RT plus RT plus RT. And there's 1, 2, 3, 4, 5. So this part and this mean exactly the same thing, but we're going to write that 99% of the time because it's shorter and quicker. All right. So stop the video. You've seen what this stuff means. Going to answer these questions here. You're going to write it out. And on this side, you're going to condense them and, I don't know, put it in the condensed form. So make it look like this part. Okay, seriously, turn off the video. All right, I'm going to trust that you did that. So 6x is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 x's. Don't overthink this. It is that simple. So 4d squared is going to be d squared plus d squared plus d squared plus 1 more. 1, 2, 3, 4. And they're all addition. It's not that bad. Now I'm really regretting this one. Only because I'm not sure what I was thinking when I wrote 10 there. Oops. Because I know it's pretty exciting to watch me writing that. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 1 more. There. That's the longhand version of it. Oh, this side will be easier. Look. All you got to do, you know there's going to be some t's because that's all that's there. 1, 2, 3, 4, 5, 6, 7, 8. 8t. 1, 2, 3, 4, 5, 6. 6r. And I don't have to count, I can see 4p. So coefficients, this has to do with adding. That's super duper important. because exponents, on the other hand, if you look down here, has to do with multiplication. So x to the third is x times x times x. So multiplication, right? We're using brackets here. Because if I tried to use the times sign in there, oh, it'd be such a mess. So look at the difference. When the 3 is out front, that means you're adding. When it's as an exponent, and now I wrote it so you can't see it anymore, it means multiplication. So R7 should mean 1, 2, 3, 4, 5, 6, 7 R's. A, B to the 9th, there should be 1, 2, 3, 4, 5, 6, 7, 8, 9 ABs. Pretty straightforward. Notice this one, it can even be stuff in brackets, but the exponent means this is my base, this is what I'm going to write. My exponent says how many times. So 2x minus 5 in brackets, 2x minus 5. So this is for multiplication. So we want to write this out. So t to the 5th, 1, 2, 3. I think I got lost. 1, 2, 3, 4, 5. That's it. All right. If you stop the video again, if you already haven't done this. Straightforward. One, 2, 3, 4, 5, 6, 7, 8. Why did 8? Okay, these ones over here, these are important. So they look like almost exactly the same question, but there's a slight difference and it makes a difference. You know what I mean? Because this negative is inside the brackets, that's going to tell me I go 3xy, negative 3xy. Okay. And if you put values in there, your final answer would actually end up being positive because a negative times a negative makes positive. And there's another 2 that cancel out there, so it'd be final positive. Now this one with that negative out front, kind of got messy at the back there, but you get the idea. So this one, because the negative isn't in the bracket, we only see it once, and then we write the 4th power only applies to the stuff that's in the brackets. Pretty important distinction if you ever see that. You're not going to see it that often, but once in a while. All right, now let's look at these. We got 1, 2, 3, 4, 5. This is going to be a to the 5th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So V, T, Z. Now, I'm just going to write it wrong over here. The fact that V, T, Z to the 11, that would actually tell me it's V times T and then 11 Z's. But that's not what I have. I have 11 of VTZ. So we need to put brackety bits and 11. It's kind of a hint that you saw them in pairs like that. All right, this last part, we are going to take this one and completely disassemble it, make it as long as I possibly can. So the first way I'm going to interpret this is this 3 out front means x to the 5th plus x to the 5th plus x to the 5th. So that was dealing with just the 3 there. So this gives you that. But because you know about exponents now too, you can even break it down some more. That's awful. One, 2, 3, 4, 5. So that's that one. And then we have a plus, and then we got 1, 2, plus 2, 3, 4. Can you see now why this is so much better than writing x times x times x times x times x plus x times x times x times x times x plus x times x times x times x times x? Whoever figured this out is brilliant or lazy in a good way. All right, let's look at these ones down here. It's a little bit tricky. Get your world on straight. What's different here than what we saw is we have d's and f's. We have 1, 2, 3, 4. So that's d to the 4th. And 1, 2, 3, 4, 5, 6, 7. And there we go. Now look at this one. We have some multiplication and we have some addition. So maybe let's look at it this way. 1, 2, 3, 4. So that can be written as t to the 4th. These are all t to the 4th. Whoops, lost my plus sign. So that gives me 1, 2, 3, 4, 5. And there we go. No, it's not going to be very often that you have to do this, but if you know what the derivation of why there's a 5 up front, what that means, and why there's a 4 there, when you get to do multiplication of polynomials or addition and subtraction of polynomials, it makes super sense and it becomes really easy. So this, although it looks, okay, honestly, it looks really messy and super simple, is the beginning of understanding this and being a math hero, which I know you all want to be.